As part of Machine Learning Foundation for Product Managers, we have been given a problem to solve. We need to predict the net hourly electrical energy output of a combined cycle power plant which uses a combination of gas turbines, steam turbines, and heat recovery steam generators to generate power. The data set given contains 9,568 hourly average ambient environmental readings from sensors at the power plant, which we will use in our model. The columns in the data consist of temperature, ambient pressure, relative humidity, exhaust vacuum, and net hourly electrical energy output, which is the target we are trying to predict. As we try to predict the net hourly electrical energy output, which is our target variable, we define the other variables as features which are temperature, ambient pressure, relative humidity, and exhaust vacuum. Our target value has numeric values and the data is structured and continuous. Hence, I will be using linear regression based supervised learning algorithm, and I will be using Excel as the tool to build the model. Using Excel data analysis, I first ran a descriptive statistics on data to check the summary of each column. As per results seen in the table shown on previous slide, relative humidity and energy output have highest standard deviation. Ambient pressure has low standard deviation and indicates low variability because atmospheric pressure does not change much generally. Also, looking at the rows in the Excel, I see that the data is clean and there are no null values in the columns. Using box plots, I identified outliers in ambient pressure and relative humidity. In relative humidity, the outliers lie between 20 and 30, and in ambient pressures, the outliers are either greater than 1030 or less than 997. Then, checking the correlation between various columns, I find that relation between AT and PE is strongly linear. Relation between V and PE is also strongly linear. Relation between AP and PE is weakly linear, and relation between RH and PE is also weakly linear. Then, as part of data preparation, as I finished my data analysis, I removed all the identified outliers from ambient pressure and relative humidity. The number of rows still remained above 9,500. Then I split the data into training set of 18% and test set of 20%. Then I built and evaluated two different linear regression models. I used Excel to build both these models, but I used different feature sets. For model 1, I included all the 4 features, whereas for model 2, I used only V, AP, and RH. As AT and V have a very high correlation, I removed AT from model 2. I used R squared as regression output metric to evaluate the model because R squared is used to understand the extent of variance in the predicted value, and higher the value, higher the quality of model. As I evaluated the model, I found that model 1 had an R squared value of 0.96, had an R squared value of 0.8. My preferred model is model 1 because R squared value of model 1 is 0.96, which indicates that 96% of the variance can be explained in model 1 as opposed to model 2, which has an R squared value of 0.8, which is only 80%.